able to see them in dark at this, in UV at this, and in under normal light, like where we are, like this. So certain things that we're not able to see here will be seen in the dark, and so on and so forth. So this is how you see the components now. So they spotted, they put so many compounds there, 1, 2, 3, 4, 5, but they are going in line. That's what it's about. So when you see like this, and then we take this plate, which is the one which is here. Like this plate is the one, imagine this one is this. Taking it into the machine here. Now this machine, now it will be able to read individually all these separations to the machine onto the computer. And then even give you the name and also the quantity of how much is present in that sample. Yes. For your investigation, maybe you just want to know the name. If TNT, like trinitrotoluene, is present, it will give you yes, it's present. But for quantification now, that's when it will calculate how much, depending on how much you are putting there, it will be able to calculate that. Oh, in that volume that you put here, there's so much of TNT. And how it calculates is, you look at the blue color there, so it will calculate the total area under that blue color. The total area in that blue color is directly proportional to the amount of substance that is present in that sample. The smaller it is, it means that it is less. The bigger it is, it means that the area, it means that there's too much quantity. Yeah. So this machine, this part of the machine only is used for application of the sample, putting the sample on the plate. And this is just a normal computer with the software that controls this, controls even that. Yeah, so you yourself, you have to tell how much you should apply here, and what quantities what are you looking for? You have to tell the machine, I'm looking for TNT in this sample. Okay. And if you have even a control, the control is something that you know, you have a TNT in the lab. You can even put, next to you, I'll put a control TNT. So you should also compare this much. So the machine that the software to compare. So you have to feed in the information, and also that one now will be reading according to what you feed the information. Yeah. So this is the HPT also. Yeah. Any questions? Just you have seen the two instruments that we have. They are used for many applications. We use it. Like I said, it uses liquid samples, isn't it? Which you can put here and which are able to move. We use also in pharmaceutics. Yes.
So you said you can, if you have solid, let's say solid compounds, and they are a mix of a solid compound, you can also analyze it.
Yes.
As well as a liquid mixture,
yes.
can be also analyzed.
Yes.
Alright, so meaning a physical or chemical compound can be analyzed.
Yes.
Alright, thank you, sir. That's what,
so if it's a solid, as long as it's able to dissolve and turn into a liquid, and then we apply it here. But if you know, it is a solid, we have to make it dissolve.
Yes.
After if it can't dissolve, it's very difficult. We have to find a way of dissolving it. So once it dissolves, we will apply it in here as a liquid. But when we apply it, we have to remove now the solvent again. You get my point? Immediately we apply it here using a syringe, a needle in here. Once it's applied using this needle, it's applied using this needle. Once it's applied, and then once it's applied using this needle, you have to take your sample through the needle as a liquid. When it goes here, it goes as as a liquid, but you have to evaporate the liquid, remove it again, because now the solid is in there, it's mixed with the material that is found on the material that is found on the plate, because this plate is a special plate, glass plate, which is coated with some kind of a silica gel. So that liquid now it was a liquid to be put on this, and then to mix with this the silica gel that is there. Yeah. So there's a gel. So if the components are separated, because this is one of the pictorials, if they are separated like this is one compound going this. There is this, there is this, there is this, there is this. If the compound of interest is this on my plate, I'm able to scratch it, to remove it and get the powder, just like I can do this and remove that powder. And if, for example, I just remove that small powder, very small powder, and put it into a test tube, a beaker, and maybe the swab came from the door, where you suspected that the person who could have ignited the fire obviously opened the door and then you swap that part, you bring it, we analyze it like this. Then at the end of the day, the machine tells me that the DNA of this person should be this part. Then I'll scratch that part, put it in a test tube, and take it to UTH where they do, or Levy, where they have opened the DNA matching lab. And then you get also a sample from me, for my DNA, for my skin, and you can match. And this person can be connected to the crime. Simply that's why.
And how long does it take?
For this machine, it's robust. It's fast. All things being equal, the analysis with this machine only takes less than 1 hour. What may take longer is the sample preparation. And because you are all investigators here, chief investigators or investigators, in any investigation of scientific nature, sample collection, sample storage, and sample preparation is very, very catchy. How do you get a sample from the scene? How are you going to store the sample? And how are you going to prepare it in the lab? So what takes a lot of time is how to prepare the sample before it comes onto the plate. We will look at the method. Maybe some methods may take even a week. We're just separating this. Once now you are ready to analyze it on here, it takes even less than an hour or so. I should have the results on the machine. But what can take longer is how am I going to prepare my sample? And how you get your sample from the field or from the accident scene or from the fire scene, how you get your sample is very important. What are you using to take your sample? Because me, if I go with you into the courtroom, you have accused me, I will be asking questions. Who got the sample? What did you use to get the sample? Maybe the sample was already contaminated. How did you store the sample? How did you transport it? Because I'm told you are coming from others. Someone told me came from Mongo. As far as Zambia. If you don't have this machine in Zambia, how did you transport your sample from here to SAC?
Now, just on the
Just the machine.
Considering the fact that you take the swab, when someone maybe opened the door, you don't know that person and maybe has even traveled, has gone back to the copper plate. Then you do a DNA test. Are you able to tell to say it's this person? Maybe it goes with when you get the samples from the same.
Yeah, for DNA matching, the two people must be there. There's no. taught and we know that each one of us, his DNA is very unique. My DNA is not his DNA, and that's the uniqueness in all of us. So if I found a sample of DNA, I characterize it, I know it. It is very difficult for me to just say it is you. Unless all of us here, we take samples. If you are suspecting all of us, take samples from that. If there is a suspect, a culprit, if I have a sample, if there is a culprit and a culprit is amongst us and we got a sample, it will match with one of us.
It's a fingerprint.
It's a fingerprint. Actually, the DNA is a fingerprint.
How do we prepare something
To be ready here.
and how do we store it?
Yeah, that's now very broad because each sample has its own unique way of getting it. If you are looking for a DNA, sometimes they will swap it from the accident scene, depending on where you experts suspect that the cause of fire was coming from here. You get your sample, and for such facilities, maybe you call experts who are good at sampling, and then they'll store the sample. If it's a human sample, if it's blood, if there was someone even got injured in the process and you get blood, I think blood should be stored at a very, very low temperature before you bring it here. But if they are just organic compounds, make sure that it's not just affected to normal sunlight. Keep it safe, that it's not disturbed. But the way you are sampling, you have to make sure that this instrument or the substance you are using, if it's a biological sample, it's very sterilized. The containers in which you are putting, obviously it must be clean, away from factors that will influence the results. You have to know your sample, what factors affect what will affect my results. Those are the things I think in sampling we look at. What is it that will affect my sample? If it's a biological sample, you find that 2 days it goes bad. If it's not kept under refrigeration, then that sample must be thrown out. If it's blood, it will be thrown out. But certain compounds, chemicals, they can stay. The only challenge we have with the chemical compounds is that avoid them being direct sunlight.
Yes, just there on DNA, because we are always taught that, let's say maybe you are just from mentioning that every individual has different DNAs. So now, just there, I want to understand I think you are experts with science. So let's say, how is it done, or how is it known that, let's say me, I impregnate the woman or the girl,